Alright, these are the notes for the polygon angle sum theorems. Our objective is to find the sum of the measures of the interior angles of a polygon and also to find the sum of the measures of the exterior angles of a polygon in this video. First thing you have to know is what a polygon is. A polygon has three sides at least. Its sides are all straight. It is a closed shape, meaning there can't be any openings, and sides only touch at endpoints. So examples of a polygon is a triangle, because that's what we've been studying for the past couple months. Also, you can have a square, a rectangle. This is also a polygon that I'm drawing. That's a polygon. This case I'm drawing right now is not a polygon because it's not closed. It has an opening. And if I draw something with a curve, so a half circle is not a polygon. And also sides can only touch at endpoints. So if you have something that crisscrosses like this, you have a whole bunch of shapes crisscross. This is not a polygon because the endpoints do not only touch at the sides, they crisscross. So if things cross in the middle or there's any intersection in the polygon, it's not really called a polygon because of that case, no intersections. So there are different types of polygons. There's a concave polygon. Polygon is concave if a diagonal contains points outside of the polygon. Meaning, if you see dents in your shape, it's a concave. Don't forget that a polygon has diagonals, and a diagonal of a polygon is a segment that connects two non-consecutive vertices, and this is going to be important. So here's the visual of your concave. Here's how you prove to someone that something is concave. So I'm going to take my line, my red line, I'm going to make it thinner. And I'm going to show you right here. So if I take and I highlight this red line, those two endpoints, A and B, those are consecutive because they're right next to each other. The definition here says if I do non-consecutive vertices and connect them, if any of those lines that I connect to non-consecutive vertices are outside the polygon, then it's concave. So here's an example. So if I connect A to C, notice that this line A to C goes outside of the polygon. Therefore, by the definition, it is concave. Again, if I take D and I connect it to E, D to E, that diagonal, it's a diagonal because I connected two non-consecutive vertices, that diagonal goes outside of the shape, therefore it is concave. So if you have one diagonal going outside of the shape or your polygon, it is concave polygon. Using the star example, if I connect A to B, because A and B are non-consecutive vertices, watch what happens. Okay, my diagonal is not outside, so this still could be considered a different type of polygon. But I got to check. I got to connect non-consecutive vertices. So if I connect C to B, these 2 points C to B are non-consecutive because I skip a point in between. And if I connect C to B, oh, there we go. There's my diagonal. That makes this polygon concave because this diagonal is outside the shape. The other type of polygon we have is convex, which is a polygon where all the diagonals are contained inside of the shape. So all your diagonals are inside. So you take obviously a triangle. There are no diagonals in the triangle because all sides are consecutive or all endpoints are consecutive. If you take this pentagon and I connect all my diagonals, if you notice that my diagonals, none of my diagonals are outside the shape. It just so happens that it creates a star. So if all your diagonals are contained inside of the shape, it's convex polygon. Then you have equilateral polygon, where all sides are equal. You have equal angular polygon, where all angles are equal. And then you have a regular polygon, where both sides and angles are congruent. Here are some prefixes to know, because we have a bi, tri, quad, penta, hexa, septa, octa, nona, and decagon. So you'll hear these prefixes a lot in this unit. So let's actually get to the meat and potatoes of this lesson, which is the sum of interior angles in a polygon. We already know that the sum of all angles in this is 180. But let's find out why the four-sided polygon is 360. So I know that all angles are going to equal 360 degrees in this four-sided polygon, and here's why. If I take a diagonal in this quadrilateral, or more precisely this polygon, notice that I created two triangles. I have one triangle, two triangles. So I have four sides. I made two triangles. How many degrees in each triangle? I know there's 180 here. I know there's 180 there. So 180, 180 is 360. That's why the sum of the interior angles in a four-sided polygon is 360. So let's check here. I have 1, 2, 3, 4, 5. I have 5 sides. So how many triangles can I construct in this 5-sided polygon, which is a pentagon? Well, I have to connect non-consecutive vertices, meaning I'm creating diagonals. There we go. So I have one triangle, two triangle, three triangles. So I created 3 triangles. I know that each triangle is 180. So that's 180 degrees. So 180 plus 180 plus 180 is 540 degrees. So I know all the angles in a 5-sided polygon, or a pentagon, is 540 degrees. Now if I go to a 6-sided hexagon, so I have 6 sides. How many triangles can I create in a hexagon? Well, I have to construct non-consecutive vertices, or create my diagonals. Oh, we made a little mistake there. Let's fix it. Here we go. So I have 1, 2, 3, 4. I have 4 triangles. So with 4 triangles, each one is 180. So I know there's 180 there, 180, 180, 180. So 180 times 4 is 720. So all angles in a hexagon are 720. So we know that in a triangle is 180. We know that in a quadrilateral it is a 360 degrees for all interior angles. For a pentagon, 5 sides, all angles on the inside have to equal 540. Hexagon, all inside angles have to equal 720. You should see the pattern here, that if I now go to 7 sides, so here there are 7 sides, and I find out how many triangles can I form by connecting my non-consecutive vertices. You should see that with 7 sides I have 1, 2, 3, 4, 5 triangles. So with 5 triangles, each triangle is 180, so I do 5 times 180, and I get 900 degrees. So I know that in a 7-sided polygon, or a septagon, I know that my interior angles are going to be 900 degrees. Now here is my octagon, so here's 8 sides. How many triangles can I construct by connecting non-consecutive vertices? Well, you should know by now that it should be 6 triangles. And let's see. 1, 2, 3, 4, 5, 6. Indeed, I have 6 triangles. So 6 times 180, because each triangle has 180 degrees, I get 1080. So there's the theory behind interior angle sums in any polygon, that the number of sides will always be two more, not twice as much, will be 2 more than the number of triangles you can construct by connecting non-consecutive vertices. So to sum it up, so the sum of all interior angles in any polygon is equal to number of sides minus 2 times 180, where number of sides is really n. So n minus 2 times 180 will give you the sum of all interior angles in a polygon. And that makes sense, because if you have a triangle has 3 sides. So 3 minus 2 times 180, we have 1 times 180, which is equal to 180. And that's what we know, that there is 180 degrees in a triangle. We're going to do more examples later in the video. So we did interior angles, now let's do exterior angles. So you should know by now that an exterior angle is linear to its interior angle. So I'm drawing my exterior angles, 1, 2, 3, 4. So your exterior angles, so in any polygon, will always be 360. So I know that angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360. The reason being is because if you actually connect these angles 1, 2, 3, 4, they construct a circle. Same thing here, that if I construct my exterior angles in this polygon, remember an exterior angle is always linear to its interior. Linear means 180, so if I take angle 1, 2, 3, 4, 5, I know that all these angles, angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5, all those will equal 360. And the same holds true for this next polygon, this hexagon, which is 6 sides. So if you take all your exterior angles and add them up, 2, 3, 4, 5, and 6. So I know that angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 will all equal 360. So the exterior angles, all added up, no matter what type of polygon you have, will always be 360. And I'll see if I can actually show you. So if I take my angles, so I'm going to circle 5 there, and I'll circle 1, and 2, and I'll show you that if I connect all these angles, I can make a circle, and a circle has 360 degrees. So I'm copying these angles. So I have these angles. I have all 5 angles. I'll show you that I can actually make a circle out of these 5 angles. Let me get rid of this square, or I should say quadrilateral. So I have all these angles, so I can actually make a circle out of all 5. So if I take angle 1 and 2, let's make this transparent. So there we go. There's angle 2 and 3. Here's angle 4. So there's angle 4, 2, 3, 4. Here's 5. And again, I'm just showing you that I can make a circle with all 5 angles, and I just need to fiddle around here with these. So here we go. So there's 4, there's 5, and angle 1 should fit right in between 3 and 5. So here we go. If I rotate this, and this is the case, yep. Oops. There we go. I just constructed a circle, and there we go. Here's my circle. So all 5 angles that were all exterior angles will add up to 360, which means it can form a circle when you join all the vertices together at a single point. So to sum up my lesson, the sum of the measures of the interior angles of an n-gon is n minus 2 times 180. So n is going to equal the number of sides in the polygon. If I want the measure of a single angle and it's regular, key here is regular, it's n minus 2 times 180 over n. So you're going to use this formula to find one interior angle measure in any regular polygon. And remember, a regular polygon has all equal sides and all equal angles. And then the sum of the measures of the exterior angles of a polygon is 360. So basically, all exterior angles will equal 360. It doesn't matter what type of polygon. And we're going to do some example problems using all 3 formulas. So I want to know what's the sum of the interior angle measures of a 7-gon. So I want to know what's all the angle measures of a 17-gon. So I know that if I take my formula, this equals the sum of all inside interior angles. So it's n is always number of sides, 17 minus 2 times 180. So 17 minus 2 is 15 times 180. You go to your calculator, 15 times 180, 2,700. So this is equal to 2,700 degrees. So that's the sum of all angles in a 17-gon. What's the measure of each interior angle in a regular nonagon? So this is 9 sides. So I want, in this case, I want one interior angle measure. So that's going to equal n minus 2 times 180 divided by n, which is n is number of sides, 9 minus 2 times 180 all over 9, which is 7 times 180 divided by 9. So we do 7 times 180, and then I divide by 9, and I get 140. So this equals 140 degrees. That's the measure of one inside angle in a regular nonagon. Now we can use some algebra to solve for missing angles. So we know that triangles have sum of 180. Now we can apply the n minus 2 times 180 rule to find missing angle measures in any polygon now, as long as we have some information. I want the measure of y, so I'm going to put x there. Okay, I have 1, 2, 3, 4, 5 sides, so I have 5 sides. So I know that the sum of the interior angles will equal n minus 2 times 180. So 5 minus 2 times 180, which is 3 times 180, which is 540. So I have 180 times 3, which is 540. So I know that all the angles in this pentagon have to equal 540 degrees. Well, I know that one is 90, one is 120, one is 150. I know that another one is 110, and another one is x. So instead of setting it equal to 180 if we're dealing with a triangle, with any other shape, you have to find what's the sum of all angles by using your n minus 2 times 180 formula to set up your equation. So we do 90 plus 120 plus 150 plus 110. That gives us 470. So we have 470 plus x equals 540. Subtract 470 from both sides, so we have 540 minus 470, and you get 70. So x is equal to 70. So this angle y is 70 degrees. There's a little more work because you actually have to find out the sum of all inside angles first before you approach these problems. Next one, we have what's the measure of one angle in the regular octagon below. Well, if it's regular, I know that all these angles are equal. So I know all the angles are equal. So I know that 1 is equal to 2, equal to 3, equal to 4, equal to 5, equal to 6, equal to 7, equal to 8. Why do I know that? Because it's regular. Regular means all sides, all angles are equal, congruent. So I know that all my angles are outside angles. So I know that angle 1, 2, 3, 4, 5, 6, 7, and 8 all equal 360, because remember, all outside angles will equal 360. It doesn't matter if it's regular or irregular. So if I know that they're all equal, I know that they're all x, because I don't know them. So I have x plus x plus x, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and I know that they're all equal to 360. So I have 8x equal to 360 divided by 8. So 360 divided by 8 is 45. So each angle here in this case is 45 degrees. Another example, let's solve for angle G. So I have 4 sides. That means the interior angles will equal n minus 2 times 180. How many sides do I have? I have 4, so 4 minus 2 times 180. 2 times 180, which is 360. So I know that all my angles are going to equal 360. So I have 120, 85, 53, and x all equal 360. So I add up 120 plus 85 plus 53, and I get 258 plus x equals 360. Subtract 258 from both sides. So 360 minus 258, I get 102. And that is the measure of angle G. So here are some problems you should try on your own and also work on the homework. If you have any questions, see me during class time, after school, before school.